In this tutorial we'll walk through the final step in the DecalMaster workflow, exporting your decals and trim sheets into your target software. This video will focus on the Unreal Engine. First, open up the Export tool. The Export tool provides the ability to assign decal atlases to the decals used in the scene, combine decals into a global mesh, and channel pack the decal atlas and trim sheet texture maps used in the scene into your desired file format. I'll start by assigning a decal atlas. Before continuing with this step, it is required that you have already created a decal atlas for any decals used in the scene. If you are unsure how to create a decal atlas, please watch the decal atlas tutorial. It is important to sort the atlases in the atlas list in order of descending importance. This is because decals are assigned to the topmost atlas that contains the decal. You can also disable atlases you don't want to assign to the decals. Additionally, you can combine geometry decals into a single mesh to increase rendering performance. It is recommended to do this unless you have an explicit reason not to. Both combining decals and assigning atlases can be undone from the Export tool at any time. This feature is useful in maintaining the iterative design workflow. Next, choose the location where you'd like to export the files to. Optionally, you can export the models in the Maya scene into an FBX file, and basic parallax occlusion mapping shaders for the engine you're importing into. This is only for convenience. You may want to export the models using a preferred method and create custom material shaders. I'll be using the basic shaders for this tutorial, so I'll leave these checked. The final step in the export process is packing the decal atlas texture maps you'll use into PNG files. You are given full control on the channel packing format and number of PNG files exported. The default channel packing format and files are designed to plug into the exported shaders, so for now I'll be sticking with them. In the export folder you'll find the decal atlases, trim sheets, and depending on your export settings the models and shader files. With the files exported, we can now move on to the steps required to import the Maya scene into an Unreal Engine project. This process is heavily dependent on your rendering pipeline. The aim of this example is to guide you through the simplest method of setting up the materials in order to correctly display the decals and trims on the imported models. I'll be demonstrating two techniques for rendering decals. The first technique uses a standard opaque material with alpha masking. The second technique uses Unreal's deferred decal material. This technique is more flexible and can achieve more compact decal atlases. However, it comes with its own drawbacks that I'll describe later. First, you'll need to import the model FBX file into the project. I'll quickly create folders to organize the different assets later. The exported model includes the materials used in the Maya scene. Before moving on to material setup, it's important to disable shadows on any decal meshes to avoid artifacts. Because I know I'm only using two base materials, I can delete all but two of the trim materials. In the future, compacting trim materials will be an optional feature included in the Export tool. I'll import the texture files as well. The next step involves creating the shader graph that the materials will use. Here's where I'll be importing the optional shader files that were exported. Once the files are imported, I'll be using the shader graph for each decal and trim material present on the target mesh. I'm copying the decal materials shader graphs over to the existing model materials. You could also replace the existing ones with a decal material instance. The decal material blend mode must be set to masked for packed atlases. After copying the shader graph, the channel outputs must be connected to the material inputs. I'll do the same with the trim materials. The next thing to do is copy the base material properties from the Maya materials. To finalize the shader graph, the texture maps will need to be connected to their respective texture samplers. Before I do that, the texture sources will need to be set to the correct color space that the material properties expect. Texture maps exported from Maya are raw values, so they need to be in linear space. With textures in the right color space, I'll connect the texture files to the material's texture samplers. I'll also need to set the trim's material properties to match the base materials. Lastly, I'll need to replace the previously removed trim materials with the two existing ones. That is material setup. You can now see the decals and trims are seamlessly blending with the base materials. This technique has a couple of drawbacks. It can lead to larger decal atlases when packing many duplicate decals. Also, if you alter the base material, then you'll need to re-export the decal atlas with the updated base material properties. The next technique does not have these drawbacks, but is more difficult to set up as it requires some changes to the engine's source code. This next section will step through setting up the deferred decal technique. This method will require generating an unpacked decal atlas. I'll quickly step through generating the atlas, assigning it to the model and re-exporting the scene. I'm also going to create a separate info decal atlas to demonstrate using multiple atlases. Because the unpacked atlas does not include material properties, when assigned to the model the decals are displayed with a basic white material, as you can see here. It's important to note that because of this method, in addition to the other textures, I'll now need to export the subset mask texture to display the subset materials. I'll now set up a new scene in Unreal and import the files. This will largely be the same process as the previous technique until we reach the decal material shader graph. This time I'll be importing the unpacked decal shader file. Again, shadows need to be disabled on the decal mesh to avoid artifacts. Like before, I'll configure the texture file's color spaces to linear. The info decal atlas material is quite simple, it only needs masked or translucent blend mode and a single texture for color and opacity. I'll then copy the shader graph to the decal atlas material. The material domain must be set to deferred decal and the blend mode to translucent. Finally, I'll connect the textures to the sampler nodes in the shader graph. This is where the subset mask is utilized. If material inputs are not provided, deferred decals display the material properties of the base material beneath them, which causes a problem for decals using subset materials, like these inset screws. They will require the subset mask to override the base material with the metal subset material only on those texels of the decal. However, Unreal Engine's deferred decal shader isn't capable of per-material property masking, only a global alpha. If we try to override Decals using the subset mask, the base material will be entirely overridden across the decal, appearing black where the subset material is not present. It's trivial to enable per-material property masking in the deferred decal shader through the source code. Because of this, I provided the instructions to modify the behavior in Unreal Engine. This can be found on the export page in the documentation website. After building Unreal Engine from the modified source code, using the multi-opacity channels you can override parts of the base material's color, roughness, and metallic properties where the subset mask is applied. I'll now finish setting up the model by using the existing base and trim materials from the last technique. And there it is. As you can see, now if you change the base material's properties, the decals will automatically match their appearance. From here, you are not limited to these basic shaders. You could use other textures such as the curvature map to generate edge wear, or create additional UV sets to blend the decals with base material textures. There are many ways to improve the look of the final result.